Alright, so this first problem here, I've got the square pyramid of Giza and I want to find the surface area. And I've got some parts labeled to help me out. I know that the square base, each side of that base is 756 feet, and I know the edge is 702 feet as marked in the image. Now, I like to use the net for this problem for the surface area. I think it'll be a little bit easier than trying to use the formula. So here I've made the net. I take the square base and I pull the triangles off each side, and I know all four triangles are identical and congruent, so if I can find one triangle, I can find them all. So the thing I recognize is that I know that if I'm going to transfer my measurements, this is my 756 feet, and this is, I don't know if I can match my colors, but we'll say this is 702 feet. Now the problem is that's the edge, and if I want to find the area of a triangle, I know that it's 1/2 the base times the height. Now the base we know is 756. That's not too bad. But the problem is, how do we find that height there? That's the issue. But what we can notice is that if we look here, I'm going to pull out the little bit of the highlighter. If I look at what I have right there that I just highlighted, that little piece of the triangle is a right triangle. And I have several of the pieces of that already. I'm going to get that highlighter off there. For example, I know that this is 702, and because that's perpendicular and it's a square side, I know that that little side here is 378 feet. It's half the length of the base. It has to be because of the way the perpendicular side comes down. So if I think about what I can use then for my Pythagorean theorem, I know that 378 squared plus h squared will give me the 702 squared. So I can shift over. I'm going to leave everything just with the squared terms for now. And then I can take the square root of both sides. And if I do all of those operations correctly, I'll get that the height is approximately 591 and 54 hundredths feet. Now I can find the area of the triangle. I know that the area of the triangle, one triangle, is going to be equal to 1/2 the base. So the base is the entire length of a side of one side, that's 756, times the height, which I just found to be the 591 and 54 hundredths feet. And this is 756 feet. Sorry, I forgot to put my units there. And when I multiply them, this is approximately 223,602 and 12 hundredths square feet. Now that's one triangle. That's like I found the area of just this single triangle here. But I don't want just one. I want all four. So, but what's nice is I know, again, all four are congruent triangles. So I know that my surface area will equal 4 times the area of one triangle. So if I multiply that area of the one triangle by 4, I'm going to use the approximate symbols here, that gives me approximately 894,408.5 square feet. And that's approximately the surface area of the Great Pyramid of Giza. Alright, now this next problem is starting to look at soup cans, which are very standardized in how we create them. And first question is asking if we remove the label, we'll see it's a rectangular piece of paper, and they want to know the length and the width of that if there's no overlap. So if I think about how do I create that, the easiest way, again, because I'm recognizing this rectangle, is to make the net for for a cylinder because that's the shape we're dealing with. So if I create that net, here I have my net. And when I recognize, I'm going to label the parts that I have. I know that the circle has a diameter of 2 5/8 inches, which is the same as 21/8. And the height that connects the two circles of the can is 3 3/4, which is the equivalent to 15/4 inches. So when I'm thinking about, it says about the dimensions, I already have one of them. Now it's a matter of, well, how do I figure out this dimension? We'll call that the length of the rectangle. I have my width, it's the 15/4. Now how do I get the length? Well, the length, if we remember, is the idea that I've taken this circle and I've peeled it and laid it flat. In other words, I've taken the circumference of my circle to make that length. Now I know that I find my circumference by taking the diameter times pi. And I know that the diameter, as we just said, was 21/8. So the circumference is 21/8 pi. So when I look at the dimensions of my rectangle, I know that my rectangle is going to be 21/8 pi by 15/4. So there I know my rectangle. Now I can work on trying to find the second question. Now the second question said, instead of dealing just with that rectangular label, let's look at trying to find the entire amount of surface area needed to create the actual can. So we're peeling the can, laying it down. How much metal was there in that place? So again, I start with the net. I think that's the easiest thing when laying this out to figure out what's going on. And as we just figured out, we said that this, here, let me get everything unhighlighted there. So we know this, oh, try this again. We know this was 21/8. We know this is 15/4. And we know that this side is 21/8 pi. So I think about, well, how do I find the surface area? Surface area is going to equal the area of the circle, and I'm going to multiply that by 2 because there's two circles, plus the area of the rectangle. Well, the area of the circle is pi times the radius squared. Well, my radius is half of the 21/8, which would be 21/16 squared. And I'm going to multiply that by 2 for the two circles. And the area of that rectangle would be the 21/8 pi times the 15/4. Now, when I calculate these different parts, I'll get that the surface area of the first part is approximately 10 8/10 square inches. And I'll get that when I multiply the 21/8 pi times 15/4, that's approximately 30 9/10 square inches, which means that the surface area used to make up a can, so the amount of metal needed to make this can, is approximately 41 7/10 square inches.